So this represents the most challenging kind of stoichiometry problem I would give in a quiz or a test type situation, because this is a limiting reagent type problem, but there's a twist. So iron 3 oxide reacts with carbon monoxide in this equation. If I start out with 22.55 grams of iron 3 oxide and 14.78 grams of carbon monoxide, when the reaction's done, how much of the excess reactant remains? So when I'm done, what I should have is either grams of CO or grams of Fe2O3 as my answer, not grams of either one of those. One of these is going to run out first, and the other one's going to have some stuff left over. So my job is to figure out how much of one of these is left over, and I don't know which one. So like always, we're going to see, is this balanced? And it is not. I've got 2 irons on this side and just 1 on this side, so a 2 goes here. Now, I've got 3 oxygens plus this one, and just 2 oxygens over here. So if I put a 3 in front here, I have a total of 6 oxygens, and then I can put a 3 here, so I'll have 3 oxygens plus these 3 oxygens for 6, and these 3 carbons and these 3 carbons, so now I'm balanced. Good. All right, let's start with our iron oxide. So 22.55 grams of iron oxide. And what I want to do is convert it into something that's on this side, so why don't I just convert it to carbon dioxide. Now there's more than one way to solve this problem. This is just the way I'm going to do it. I want to see how much carbon dioxide gets made if all of this iron oxide works, and then I'll see how much carbon dioxide gets made if all this carbon monoxide reacts. And the smaller of those two is going to tell me what the limiting reagent is. All right. So 1 mole of this ends up having a mass of 159.69 grams. And every 1 mole of Fe2O3 reacts to make 3 moles of carbon dioxide. And every 1 mole of carbon dioxide has a mass of 44.0 grams. Cool. When I run this through my calculator, I end up getting 18.66 grams of CO2. So that's how much CO2 I would have if all of this iron 3 oxide reacted. If all of my carbon monoxide reacted, a mole of carbon monoxide weighs 28.01 grams, and 3 moles of carbon monoxide reacts to make 3 moles of carbon dioxide, and every mole of carbon dioxide still weighs 44.00 grams. And when I run this through my calculator, I get 23.22 grams of CO2. So what that tells me is that my limiting reagent is iron 3 oxide. This is the one that's going to end up running up first, which means I'm going to have excess CO. So now what I need to do is figure out how much CO is used in this reaction. I don't know how much is used. I know how much I was given, but I don't know how much is used. And so to answer this question, how much is used, I'm going to start with my grams of iron 3 oxide and figure out how much carbon monoxide is used to react with it. Because I know this is the limiting reagent. It's going to run out. And when it does, it's using up carbon monoxide. So how much gets used? So a mole of this stuff weighs the same as it did up here. And a mole of iron 3 oxide ends up reacting with 3 moles of carbon monoxide. And every 1 mole of carbon monoxide ends up weighing 28.01 grams. When I run that through my calculator, I get 11.88 grams of carbon monoxide, and that is used. Okay, so that's how much gets consumed in this reaction. So in order for me to figure out how much is left, 14.78 grams of carbon monoxide was given, 11.88 is used, and the difference is 2.90 grams of carbon monoxide. That is the answer to my question. Took a lot to get there, and this is really sort of the thinking point on it. What amount of carbon monoxide is used. And once I know how much is used, I can compare it to how much I was given, and that tells me how much is left. And this is what I was looking for. A really important skill for this or any other chemistry question is trying to figure out what does my answer look like in terms of units. If you can get to that, that's a really big help. All right, good luck.